So number 12 and 13, it's all about log expressions, no equal signs here. It wants us to expand this. Before I expand it, you just want to recognize how many times do I write down the word log, and this happens to be log base 10. You have this gets a log, this gets a log, and this gets a log. Whenever I see radicals, I want to convert it to fractional form. This is power over root. The root is 2, 1/2 power. If this were cube root, it would be 1/3 power. I start out by writing log x, and I pull that exponent in front using my product rule, my power rule rather. In between here is multiplication that gets converted to addition. Log gets its own, y gets its own log, and you pull that 3 in front. The division symbol is subtraction. Z gets its own log, and you pull that 1/2 in front. Now you have an equivalent log expression. This and this is equivalent. And you could have done this if it were part 1 with mock substitution, or at least check it with mock substitution. With number 13, this is when you have this stuff in the beginning of a question. We call this a log expression with substitution. And you save this part for last, and I'll explain why. Do you see a log x here by itself, or a log y here by itself, or a log z here by itself? No, you don't. But perhaps when we expand this, you might see these 3 things, and then you can replace those things with the a, the b, and the c. So once again, we're going to start by getting rid of that radical and making it the 1/2 power. And then we expand this. This is almost exactly the same as before, except the other one had a cube here. So you get your 2 log x plus your log y minus your 1/2 log z. And I just want to explain, these are completely 2 different questions because the other one had a cube here. It's just pick the same one. So now I have the log x, and log x means a, and I write it in its place. I have the log y, and that's a plus b, and I have the log z, and that's a plus 1/2 c.